2.3, analyzing rational functions. So now what we're going to do is, we talked about initially what graphs look like for rationals in 2.2. This is going to set the rules out very clearly. So if you have a rational, the first thing you want to do is look for the vertical asymptote. So first, always simplify your rational equation if it can be simplified. If you have a factor that only appears in the denominator, right here, right, see x minus 2, you're going to have a vertical asymptote. So all you do is you take the denominator, set it equal to 0. We find out x equals 2, right? Because x can't be 2, because if we plug a 2 in here, that makes that 0. So then we have a vertical asymptote. Now, here's a really interesting point. It's called a point of discontinuity, and it's basically a hole in the graph. First, simplify your rational equation. So here we have x squared minus 4 on the top. We can factor that, right? It's a difference of squares. So we have an x minus 2 and an x plus 2. So then what happens is these x minus 2's, right, reduce. So what we have is we actually have a hole in the graph. So the hole in the graph is at x equals 2. Now, when we want a hole in the graph, we need an x value, we need a y value. So once we've simplified this, we end up with f of x equals x plus 2, right? And we can graph that, that's just linear. And what we do is we take that x equals 2 and we plug it into the new equation. Normally it's always in the original, but in this case it's to the new equation. So we plug it in. So x is 2, so 2 plus 2 is 4. So our point is 2, 4. So what you do is you draw your linear out, and then you put a little circle at 2, 4. There's a hole in the graph because it doesn't exist in that case, because we plug it in, right? It makes a point of discontinuity. It makes a non-permissible value. Okay, so the first there was to find the vertical. Second point was to look at a point of discontinuity in a hole. Now, next page. This is the one where there's 3 options, and this is the horizontal asymptote. In grade 11, the only one we ever did was the horizontal asymptote was on the x-axis. Now in 12, we're changing that. Okay, so there's a couple of things. The degree of the denominator, this is the first one, is larger than the degree of the numerator. So this is a 2x, so there's a 1 up here, right? And this is an x squared. That's easy. That's the simple way. We know our horizontal asymptote is on the x-axis. Bang, you put it in there, and then you can do the rest of it. The next one is when the numerator is the same degree as the denominator. So in this case, we have an x squared and an x squared. And again, we factor the bottom here because you should always factor. But in this case, since they're both the same degree, we look at the leading coefficient. So we have a 3 up the top and a 1 in the bottom. 3 divided by 1 is 3, so we have a horizontal asymptote at 3. Okay? So first one, denominator's larger. Second one, they're the same degree. Now here's the weird one, and we're not going to see a lot of these in this course. You just got to know about it. This is when the degree of the numerator is larger than the degree of the denominator. And this is where you get your oblique asymptote. And to do that, again, we do synthetic division, right? So we have an x squared. So we have a 1, 0, 0, because we got to fill in all the blanks. -1 goes out the front, we do all the work. So we end up with y equals x minus 1, there it is there, plus 1 over x plus 1. This first part is the part that tells you what the oblique asymptote is. So that gives us the equation for our oblique asymptote. Okay? So horizontal, 3 options. Larger degree on the bottom, same degree, larger degree on the top. So that's honestly the hardest part of this one, because that really determines where your horizontal asymptote is. Okay, third page now is just kind of the fill-in stuff. So when you're graphing this, and this is useful to find what the equation looks like, you can find the x-intercepts and you can find the y-intercepts. And this is just straight algebra. So to find the x-intercepts, you set y equal to 0 and solve, right? We set y equal to 0, cross multiply, that whole bottom's going to disappear. So we end up with 0 equals 2x plus 6, rearrange it, bang. There is our x-intercept. To find the y-intercept, you set x equal to 0 and do all the math. You end up by 6 over 6, or 1 in this case, right? So key things. Let's look back here. Vertical asymptote, right? Point of discontinuity, well, factor, sorry. Simplify always. Find your vertical. See if there's a point of discontinuity. There might not be. Look at your horizontal asymptote, 3 different options, right? And then x-intercepts and y-intercepts, right? That's kind of the key. Those are the main rules. So that should help you. Have those rules in front of you when you're working through the equations and questions and stuff, and you should be able to get this. Okay, so let's look at some examples. That's the kind of key thing here. So compare the behavior of f of x equals x squared minus 2x over 4 minus 2x and x squared plus 2x over 4 minus 2x. So the difference here is this is positive here and this is negative here. So let's look at some of the different things. So the top part. Right here, let's look at this. Let's look at the first equation. Is it factorable? Yeah, of course it is. So the top, we can pull out an x. So we end up with x minus 2. Now, the bottom one, hey, you got to remember, rearrange it first. Always, always, always. So we end up with a negative 2x plus 4. What can we pull out of that? We pull out a negative 2. Oh, look. We have something that's the same in the numerator and the denominator. So once we factored it, we realized, hey, there's going to be a hole in this graph. And you can see on this graph, I've already graphed it, there's the hole right there. Well, how do we find that? Okay, so we reduce the whole thing. So we can reduce the x minus 2 in the numerator and the denominator, gives us negative x over 2. But there's a couple of key things. The hole, so what number do you plug in here? Back up here, or here, it doesn't make any difference. So we plug in a 2, so that's the x value of our hole. Now, where do we put that into? Well, you plug it into this right here. Remember, plug it into the reduced one. So negative 2 over 2 is going to give us the negative 1. So if you look, our hole is negative 2, negative 1. Now, can we graph this? Yeah, f of x equals negative x over 2 is just linear, right? It starts at the y-intercept of 0 at the origin, goes down 1 over 2, right? So down 1 over 2, down 1 over 2, down 1 over 2. And then we put in our little hole at the point of discontinuity. So that one's pretty easy to do, right? The key there is to find the hole. Okay, now, second one. The only difference again was this one's positive. So let's go back and see what we can do here. Now factor the second one. When we factor it all down, oh look, nothing can be reduced. So there's nothing to reduce. So but where's our vertical asymptote? Oh look, right? We plug. What number do we plug in there to make that 0? We plug in a 2. Right? That's going to be our vertical one, right there. Now, how do we find the rest of the stuff? Honestly, with a graph like this, you'll probably just want to do a table of values if you're not using Desmos, right? So then what you would do is a table of values, pick a bunch of values of x, get the general shape of this one. But all we're doing in this case is we're comparing those two graphs. I mean, those equations look pretty similar. The only difference was a positive and a negative, and it's quite a varied graph. Okay, last page here. Match each graph with the equation. Ooh, matching questions. They're so much fun. So let's look at this first one. So we have an x squared plus 2x, and we have a difference of squares at the bottom. So if we look at this one, we factor everything, those reduce, we end up with x over x minus 2. But do we have a hole in this graph? Yeah. Where is the hole going to be? It's going to be, well, what do you plug into here or here to make that 0? You plug in negative 2. Then we take negative 2 and plug it into this one, right? So it's kind of a dead giveaway. There's a hole in this graph at negative 2, right? There it is there. So that one goes with the second graph. Okay, what about this one? 2x plus 4 and x squared plus 1. There's no permissible values. Huh? What do you mean there's no permissible values? Well, there is no way that can be 0, right? Because no matter if whatever value of x we pick, whether it's positive or negative, when we plug it in to square it, it's going to be positive anyways. So you get a really weird looking graph, and you actually get this one at the top here, which is kind of the bump in the graph. And again, you can do that with the table of values. What about this bottom one? So this bottom one factors this one into x plus 2, x minus 2. There's nothing. Hey, but this one has double vertical asymptotes. One at negative 2 and one at positive 2. Right, there they are there, and then we get that weird shape there. And these ones I've drawn in the asymptote. So it's the bottom graph. And again, if you're really struggling with this for the general shape, table of values always work. They give you a general idea of what to do. Okay, so that is 2.3. Now, there is no lesson 2.4 because it's actually part of the 2.2. So you can move on to the exercise 2.4, but look back at 2.2 if you have any questions.